Welcome back to the deep dive. Today, we are walking a tightrope.
Small chuckle. We are indeed.
And I don't mean that just metaphorically. Well, okay, I do mean it metaphorically, but in the world of enterprise software, the drop is just as terrifying.
It's a very high-stakes walk, for sure. One wrong step, and things can go very wrong.
Extremely high stakes.
Mm.
We are wading into the murky and I think often very misunderstood waters of SAP credit management.
Mm-hmm.
Now, if you're listening to this, you likely know the basics. You know what a credit control area is. You probably know what a block is.
You've definitely seen a sales order get stuck.
Oh, absolutely. But today, we aren't talking about the standard stuff.
Mm-hmm.
We are talking about the moment the standard stuff fails.
Which happens, let's be honest, a lot more often than the sales brochures would like you to believe.
That's it, exactly.
Yeah.
We are looking at a very specific, very thorny problem that seems to pop up in almost every major implementation I've ever seen. It is. It's the battle between the nuance of real-world business agreements, the handshakes, the special deals, all those I know a guy arrangements,
those exceptions.
the exceptions, and the rigid, almost binary nature of out-of-the-box software. We have a stack of documents here. We've got technical guides, functional specs, and some real war stories from the field that all focus on one mission.
And what's that?
How to tell the system to behave intelligently when the configuration menu just runs out of options.
So we're moving from being a configurator, someone who just ticks boxes in the IMG,
Right.
to being a solution architect. That's the real shift we're exploring today, isn't it? It's a change in mindset.
It's a huge change in mindset. So let's set the scene with the scenario from our source material. This is the classic case. I mean, it's almost a textbook example of easier said than done. You have a massive global company. They're completely data hungry. They want to track credit exposure for every single customer. I mean, everyone. Every mom and pop shop, every government entity, every giant conglomerate.
So no exceptions on the tracking side.
None. If they buy a single widget, the company wants to know exactly how much credit is being used at that moment.
Which, is just good financial hygiene. In today's world, data is king. You have to know your total risk exposure at all times, regardless of who the customer is. It makes perfect sense.
It makes total sense. So track everything is requirement number one.
Oh.
But, and here's the hook, here's where it gets tricky, they only want the system to actually stop a shipment to trigger that hard block under very specific, very complex conditions.
Okay, here we go.
So specifically, they want to block a sales order only if the customer is in a high-risk group A and D. This is the real kicker. The order they are placing is a standard order.
So they want conditional logic. They're mixing variables. It's not just who is the customer, it's who is the customer and what are they buying, or at least what kind of transaction is it.
Exactly. Because if that same high-risk customer places, say, an urgent order or a rush order, they want to let it through. Don't block it.
Right, maybe they need the revenue. Or it's a contractually obligated emergency shipment. Can't stop that.
Can't stop it. Or, on the flip side, if a government customer who technically owes millions and is way, way over their imaginary limit places a standard order, well, let that through too.
Because the government always pays.
Yeah.
Eventually.
Eventually. So on the surface, if you explain this to a sales VP or a CEO, they're just nodding their head. It sounds perfectly reasonable.
Of course it does. Don't block the rush orders. We need that cash flow. Do block the standard ones if they don't pay. I mean, in plain English, it's simple.
But if you explain this same requirement to a junior SAP consultant, you might actually see the color drain from their face. They might start sweating a little.
Chuckles. Oh, yeah.
So why? Why is this simple business logic such a massive technical headache?
Well, it all comes down to how let's call it the brain of SAP credit management, that's transaction OVA 8 for those playing along at home, how it's wired. It's incredibly binary.
Binary, how so?
It thinks in 3 dimensions and 3 dimensions only. Credit control area, risk category, and credit group.
The holy trinity of credit configuration.
That's it. And standard SAP is fantastic at saying, if you are in the high-risk category, you get checked. Simple. But it is terrible at saying, if you are high-risk A&D, you're using a specific order type A&D, maybe you're in a specific division, then check, but otherwise just track.
So the standard configuration grid it doesn't have columns for those extra variables.
Not at all. It's a 3x3 grid. and the business is asking for like a 5x5 matrix, the tools don't match the problem.
So the consultant, they look at the requirement and their first thought is, well, okay, I can just turn off credit checks for the rush order type entirely.
Yeah.
There is a global switch for that in VOV8, right?
Yes, exactly. In the sales document type configuration, there's a little checkbox, check credit. You can just untick it.
But that's a nuclear option.
It's a huge nuclear option. It turns it off for everyone who uses that order type. High risk, low risk, government, everyone. And you completely lose that tracking capability we just established was requirement number 1.
So you can't say, turn it off, but only if the customer's the government. That's not a thing.
That's not a thing. And conversely, you can use the risk category to say, don't check this customer. But then you can't turn around and say, oh, but do check them if they happen to buy a standard order. You see the problem. We have a requirement that demands this matrix of variables, customer group versus order type.
Right.
And the standard system only gives us these like big linear switches, on or off.
So we're hitting a wall. The IMG, the implementation guide, it just doesn't go deep enough. And this is where so many projects stall. Or, even worse, they try to force the business to change their process to fit the software.
The dreaded, sorry, you can't do that because SAP says no.
Which is the absolute worst answer you can give a client.
It's basically admitting defeat. It's saying the tool is more important than the business need.
So the mission of this deep dive today is to figure out how to say yes. We are going to leave the safe harbor of configuration and sail right into the open ocean of AB app logic.
Here we go.
We're talking user exits, we're talking requirement routines, and we're talking BIIs. We are going to architect a solution that bends the system without breaking it.
And to extend your metaphor, we need to navigate very carefully because there are sharks in that water.
Chuckles.
There are. If you mess up credit logic, you don't just get a simple error message on the screen. You might accidentally stop revenue for the entire company. You could block every order that should go through, or, even worse, you ship millions of dollars of product to a customer that's about to go bankrupt.
That is terrifying. Okay, so before we even think about writing code, we need to understand the architecture. We have to visualize exactly what happens when a user hits that save button on a sales order. Walk us through the timeline, like millisecond by millisecond. What is the system actually doing under the hood?
Okay, yeah, this is critical to visualize because the save process is a very distinct sequence of events. To the user, it feels instantaneous, right? They click, it's done.
Right, it's magic.
But under the hood, it's more like a relay race. First, the user hits save. The system immediately checks the really high-level gatekeepers. It looks at VOV8 is credit active for this document type at all. Then it checks OVA is automatic credit control assigned to this sales area.
These are the big on-off switches, the main circuit breakers.
Exactly. If both of those are on, then the system enters the OVA8 settings. This is where it looks up your specific combination. Credit control area, risk category, and credit group. And based on that, it gathers the rules. It says, okay, for this combination, I need to perform a static limit check, and I need to check for the oldest open item. It's basically building a to-do list for itself.
It's gathering its instructions.
It's gathering its instructions, and then comes the critical moment. The source material here calls this the intervention point.
That sounds ominous. The intervention point.
Well, it is. This is where the system checks for what are called requirements. Specifically, routines you can define in transaction, VOFM, or it calls a user exit. This is our gatekeeper. This is the moment where the system pauses and asks, okay, I have this to-do list of checks. Should I actually run them?
Ah, so this is where we inject our custom logic.
This is exactly where we have to do it.
So normally the system would just run the math. It would say, limit is 100,000, the new order is for 150,000, block. But at this intervention point, we could step in and say, hold on a second, I know the math says block, but let's look at the context.
Precisely. The custom logic we write acts as a filter. If our logic returns a signal that means true or go, the standard mathematical check runs. If our logic returns false or stop, the math is skipped entirely for that check.
And if the math runs and fails, what happens then?
Then the status field, it's VBUKCMGST, for those taking notes at home, it turns to be B for blocked. And at that point, the business process grinds to a halt. The delivery cannot be created. The warehouse doesn't get the pick ticket. The truck doesn't leave the dock. It's a full stop.
Okay, so we know where we need to intervene. We've found the chink in the armor. Now let's talk about how. The source material proposes a solution strategy that involves something called a matrix table. But before we get to the table itself, there is a golden rule. mentioned here in big bold letters in our notes.
I think I know which one you mean.
Never hard code values.
This is the hill I will die on, honestly. If I could tattoo this on the forehead of every junior developer I meet, I would.
Let's admit. It seems like such a small thing, though. Why is it such a cardinal sin?
Yeah.
What's really so wrong with writing a little piece of code that says, if order type equals ZOR? I mean, it takes 5 seconds to write.
It takes 5 seconds to write, and it takes 5 years to regret, because today, the business wants to check for ZOR. Fine. Tomorrow, they launch a new product line, and suddenly they also want to check for ZOR too.
Okay.
The day after that, they acquire a competitor, and now you need to add ZOR 3. Or maybe they decide ZOR isn't even relevant anymore. If you hard-coded ZOR into the ABAPU code, every single one of those simple business changes requires a developer.
Which means you have to open a ticket.
You open a ticket, you have to find a developer who has time, they have to check out the code from the repository, they change ZOR to ZOR2, then you have to create a transport request, you have to get that moved to the quality assurance system.
Then you have to do regression testing to make sure you didn't accidentally break something else.
Exactly. And then you have to wait for the weekly or maybe monthly release window to move it all into production.
So what was a simple business decision? Hey, let's start tracking this new order type. It becomes a 2-week IT project. Minimum.
Minimum. It's slow, it's expensive, it's incredibly rigid. You're building a shackle for yourself. A good solution architect doesn't build shackles, they build keys. You want to empower the business, not enslave them to the IT release schedule.
And the key in this case is this Z table, ZSD credit rules.
Right. Instead of putting the business rules in the code, you put the rules in a custom database table. You design columns for all the variables the business actually cares about. So in our scenario, we'd have columns for sales organization, VKORG, order type, AUR, and customer group, KDGRP.
And then, what, a final column that's just a flag, like a checkbox.
Exactly. Maybe call it block active or something simple. It's
Yeah.
just a checkbox. An X means yes, perform the block. A blank means no, just track.
And you would build a maintenance view for it.
Yes, using transaction SM30. This is the absolute game changer. This simple view allows a business user, maybe it's the credit manager, maybe a designated super user, to go in themselves and say, hey, we've launched a new ZOR2 order type. We need to start checking credit for it.
So they just add a new row on the table, check the box, hit save.
And it's done instantly. No IT involvement, no transport, no waiting. The change in system behavior is immediate.
That is so sleek. I mean, you're empowering the business to own their own rules. You're turning what was a coding problem into a simple data maintenance task.
And the beauty is the code becomes incredibly simple and stable. The ABAP code doesn't know about ZOR or government or high risk. The code just says, go look at this table. Find me a row that matches the current order. If you find a matching row with an X in it, run the check. If not, skip it. The code becomes agnostic. It just executes the logic that's defined in the table.
It's incredibly elegant. Okay, so we have the strategy. We know we aren't hard coding. We're using a control table. Now we face a fork in the road. Depending on what version of SAP the client is running, the actual implementation looks very different. Let's start with implementation path A, the classic SAP ECC world. Or even, as you mentioned, S/4HANA if they haven't activated the new financial supply chain management or FSCM module.
Yeah, the old school way. But it's still very, very common. A lot of companies are still running on these rails. In this world, our tool of choice is VOFM, those requirement routines we mentioned earlier.
VOFM always sounds like a radio station to me. You're listening to VOFM, the voice of custom logic.
Laughs. If only it were that entertaining. No, it's a repository for formulas and little snippets of code. To get there, you go to Transaction VOFM, you navigate through the menu to requirements, and then you select credit checks. You'll see the standard ones there, like 001 at 1002. We need to create a new one, something in the customer namespace, so say 901.
Inside this new routine, 901, that's where we put our table lookup logic.
That's exactly where it goes. And here is the key technical concept for anyone listening who has to do this. Return codes. In these VOFM routines, the system is waiting for a very specific signal from your code. It's a binary signal. If your logic sets the system variable SYSUBRC equals 00, that means proceed. Go ahead, perform the check, do the math.
And if you want to skip it, if the table says no block,
you set SYSUBRC equals 4. That magic number tells the system, nothing to see here, move along. It effectively acts as an abort command for just this one Check.
Okay, that seems simple enough. So your code reads the Z table. If the table says don't block, you said SYSUBRC equals 4. If it says block, there's no entry, you said SYSUBRC equals 0. And then you have to wire this new routine up to the configuration, right? It doesn't just run by itself.
Correct. You have to go back to our old friend OVA8, the credit check configuration. You find the specific check you're trying to control, let's say the static limit check, and you'll find a field there called no credit check, which is, I admit, a confusingly named field because it's actually the requirement field.
Right.
And in that field, you assign our new routine, 901.
So now, whenever the system tries to run that specific credit check, it first has to ask routine 901, hey, do I have permission to proceed with this calculation?
Exactly. And there's a nuance here the source material is very clear about. This routine runs before the limit is even checked. It's a true pre-check. If 901 says skip, the system doesn't even bother looking at the credit limit or the exposure. It just approves the document for that check and moves on.
Okay, so that's the classic path. Very clear. Now let's look at the future. Implementation path B, SAP S/4HANA with FSCM. So FSCM, Financial Supply Chain Management. Why is this so different? Is it just a rebrand of the old stuff?
No, not at all. It's a fundamental architecture shift. In classic SAP, the credit checking was an internal calculation that happened right inside the sales order SD module. It was all one big program looking at local tables within the same, let's call it the same brain. In S/4HANA with FSCM, credit checking is a service call.
A service call? You mean like an API call?
Essentially, yes. The sales order in the SD component calls out to the separate credit management component, FSCM. It basically packages up the data and sends a message, hey, FSCM, I've got an order here for customer X for $500. Is this guy good for it? And FSCM does all the math in its own silo and then replies with a simple yes or no.
So if it's a call happening between two components, where do we intervene? Do we, like, cut the phone line?
Pretty much. We want to stop the call before it even happens, or at least intercept it. The tool of choice here is different. It's not VOFM, it's a BADI business add-in, specifically the SD side BNI called BADI XDCM.
And there's a specific method within that DI we'd use.
Yes, the method is called FSCM Credit Check Order.
Sounds very authoritative.
It is. It's the main gate. Now, remember, in the classic world, we used return codes 0 and 4.
Right.
In the BADI world, it's more modern. We use parameters. There is a specific changing parameter passed to the method called CV Check Credit. It's a Boolean value, true or false.
So instead of setting SYZBRC equal 4, we just set this CV Check Credit parameter to false.
Exactly. Our logic is the same. We read our Z table. If the table tells us no block for this scenario, we just set CVGJ credit to false. The SD module sees that parameter is false and says, okay, I guess I won't bother calling FSCM for this one. And the process continues.
It actually seems a lot cleaner, a lot more explicit than remembering what SYSUBRC means.
Oh, it is. It's object-oriented. It's easier to read, much easier to maintain. But the core logic principle is identical. Check the custom table, and based on the result, decide whether to proceed with the standard check.
All right, so we've designed our elegant table. We've picked our implementation path, either the old school VOFM or the new school BADI. We're feeling pretty good about ourselves. We've solved the business problem, or have we?
We have solved the blocking problem, but, and this is a huge but, here is where it gets really interesting. This is where the source material pivots to a section called complex variations and gotchas. This is the stuff that separates the junior consultants from the senior architects.
Because the simple solutions we just described, skipping the check entirely, they have a massive hidden flaw. Is that right?
A flaw that could completely ruin your financial reporting. It's a trapdoor that I would say 90% of consultants fall into the first time they try to build something like this.
Okay, you have my attention.
Yeah.
Let's talk about gotcha #1, the update versus check dilemma.
This is absolutely crucial. So you have to remember that in SAP, credit management does two distinct things. One, it checks if you are over your limit. We've covered that. Two, it updates the credit exposure tables. It adds the value of your new sales order to the customer's total used credit.
Right. Makes sense. I just bought $500 worth of stuff, so my debt goes up by $500.
Yeah.
The system has to record that.
Here's the problem. In many standard setups, depending on how your update groups are configured, if you use our logic to fully skip the credit check, meaning you return SYSUBRC equals 4, or you set the BADI parameter to false, the system often assumes, oh, okay, this order isn't relevant for credit at all, so it skips the update too.
Whoa, wait a minute, say that again. So the order goes through, the customer gets the goods, but the system doesn't record the debt.
That's exactly what can happen. The customer buys $1 million worth of goods, and their credit usage in the system stays at 0. You've created a ghost order from a credit perspective.
That is a complete disaster. The financial reporting would be totally wrong. The CFO would look at the credit exposure report and see total exposure, $0, while the warehouse is emptying out. And this violates the original requirement.
Violates the number one requirement.
The source material was clear. The business wanted to track credit for everyone, but only block some. If we skip the check, we stop tracking.
Correct. We satisfied the don't block requirement, but we completely failed the track everything requirement. We solved the symptom, but we kind of killed the patient.
So what is the expert fix? How do we possibly thread this needle? How do we track the value of the order, but ignore the block status it generates?
You have to perform a sleight of hand, a bit of programming magic. The key is you don't skip the check. You have to let the standard math run. You let the system calculate the limit, check the exposure, and most importantly, attempt to update the credit exposure tables.
But wait, if the customer is over their limit, the standard math will block the order. That puts us back at square one.
It will. And that's where step 2 of the magic trick comes in. We manipulate the result after the standard check has run, but before the save is finalized and committed to the database.
Okay, that sounds sneaky. I like it.
We use a different kind of enhancement point. A user exit, typically in a program called LVKMPFZ1 in the classic world, or with some specific logic in the B80I after the standard check returns. The logic flow looks like this. First, you allow the standard check to run, let it do its job, let it update the exposure value.
Okay.
Second, you immediately check the result. Is the status VBUKCMGST now set to B for blocked?
And if it is?
If it is blocked, now is when we finally check our Z table for the first time. And if our Z table says, actually, hold on, this guy is a government customer on a standard order, let him through, we then programmatically force the status back to A for approved.
So you let the system block it for a literal millisecond. Then your code unblocks it before the user even sees the screen refresh or gets a message.
Precisely. By letting the check run, the system does the hard work of updating the exposure tables S066 and S067 in Classic, or the UCOM item table in FSCM. We get our data, we satisfied requirement 1, but by overriding the final status at the last possible second, we prevent the business interruption. We satisfy requirement 2. It is the absolute best of both worlds.
That is such a crucial insight. If you just took the simple route and skipped the check, you'd be flying completely blind on your total credit exposure. This is why you have to understand the full life cycle of the transaction, not just the check itself.
Exactly. You have to think about the downstream effects. You always have to ask, if I turn this little thing off, what else turns off with it?
Okay, that was a big one. Let's talk about gotcha, #2. The source calls it split criteria, header versus item level logic.
This is another one that causes all sorts of headaches. Standard credit checks are almost always header level. That means the whole document, the entire sales order, is either blocked or it isn't. It's one decision for the whole thing.
Right. But what if the business comes to you and says, we want to block them if they buy hardware, but we don't want to block them if they just buy a service contract?
And of course, a single sales order can have both on different lines, a laptop on line 10 and the warranty on line 20.
Exactly. So if the laptop triggers a credit block, the service contract gets stuck too. The whole order just stops.
Which the business doesn't want.
So how do we handle that? If the check itself is at the header, how can we make it smart enough to look at the individual items?
You need looping logic in your enhancement. Your code needs to look at the internal table that holds the item data during processing. In this case, it's a table called XVBAP. You have to write a loop that goes through every single item on the order, one by one.
And what are you looking for inside that loop?
You have to work with the business to define a rule. A common rule would be something like, if I find any item on this order that is considered risky, like something from the hardware material group, then I must allow the standard block to proceed. But if all the items on the order are considered safe, like they're all from the service material group, then and only then can I bypass the block.
So it's sort of an all-or-nothing check that you build yourself based on the composition of the shopping basket.
It has to be. You can't really block half a sales order easily in standard credit management. I mean, it's a blunt instrument. So you have to decide programmatically, is this order predominantly risky or is it predominantly safe?
And this requires really clean logic. You can't just check the first item and then give up.
No, and that's a classic programming mistake. A developer might write code that just checks the first item. Oh, item 10 is a service, we're good. But then item 20 is a $50,000 server. Oops, you just accidentally released a massively high-risk order because you were lazy with your loop.
Laughs. Oops, indeed. Yeah, that would not be a good day. That leads us very nicely into section 7 of our notes here, the run book. Because if I'm a solution architect, I can't just walk over to a developer and say, go fix the credit check. I need to write a specification document.
The functional specification, the
Yes.
FS, this is your contract with the developer. It's the blueprint for the solution.
The source material here even gives us a template ID, SAPSDTOP50, what absolutely needs to be in that document.
Precision. You cannot be vague. Don't write check the Z table. You need to write execute a select single from table ZSD credit roles where the key fields VCO, ORG, AUART, and KDGRP match the values from the sales order header.
Be incredibly specific about the fields and the logic.
Incredibly specific. You have to define the trigger. Sales order save. You have to define the inputs. Sales area data, net value, customer group. And you must define the logic flow with painstaking clarity. Step 1. Fetch customer group from table KNVV. Step 2. Check our Z table with these keys. Step 3. If a match is found with a blank block active flag, then force VBU zero ambiguity.
And what about the standard configuration steps? Even with all this custom code, we still need to set up OVA8 properly, right?
Absolutely. This is a common mistake. People think custom code replaces config. It doesn't. The custom logic sits on top of the standard config. You still need your credit control area defined. You still need your risk categories. You still need your static checks enabled in OVA8. If you don't have the basic configuration in place, the custom logic has nothing to control. It's like installing a high-tech smart lock on a door that has no hinges. It's useless.
Yeah, right. Good analogy. Now let's talk about testing. The source really emphasizes creating a testing matrix. Why is this so uniquely important for something like credit?
Because credit logic is invisible. It's not like changing a field on the screen. You can't see if it's working until you hit save, and either the order saves or it doesn't. You have to rigorously prove that it works correctly for every possible business scenario.
So give us some examples from a robust test plan. What would that look like?
Well, first you need a positive test. You take a high-risk customer. You create a standard order that goes way over their limit, the expectation. The order must BLOCK.
Okay.
Then you need a negative test. You take that same high-risk customer, but this time you create a rush order. The expectation, the order must pass, even if it's over the limit. That tests your custom logic.
Makes sense.
But you also need what I call a safety test. This is the one people forget.
What's a safety test?
You need to ensure the standard checks still work when they're supposed to.
Yeah.
So take a risky group customer who is under their credit limit. Your custom logic might say, yes, check them, but the standard math should say, pass.
Yeah.
You need to verify that your custom logic doesn't accidentally block people who actually have plenty of credit.
Oh, that would be embarrassing. Congratulations, you implemented a custom credit check, and now nobody in the company can buy anything, even if they have perfect credit.
That is what we in the business call a resume-generating event.
Laughs. I like that. I'm going to use that. Okay, let's move to section 8, troubleshooting. So you've built it, you've written the spec, you've tested it, and on Monday morning, it's not working in production. The source calls this the detective work.
And it really is detective work. Debugging credit checks is notoriously hard. It frustrates even the most experienced developers.
Why is it so hard? Is the code that complex?
It's not the complexity of the code, it's when the code runs. A lot of the time, the core credit check logic happens in what's called an update task. This means it runs in a separate process in the background after the screen has technically cleared and said sales order saved to the user.
So if you just set a normal breakpoint in the code,
The system might breeze right past it. It never stops because the debugger is watching the main process, but the code is running in a different memory space.
so you have to use update debugging specifically.
Yes. It's a special setting. You turn on the regular debugger with H, but then you have to go into the settings menu and explicitly check the box for update debugging. This tells the system to intercept those background processes. For credit checks, it's often the only way to see what is really happening inside the logic.
And when you're in there, what are you looking for? Where are the key places to look?
In the classic world, the main program is SAPLVKMP. In the FSCM world, it's the class CLUKM FUCOD. But the holy grail variable, the one you are watching like a hawk through the whole process, is VBUK-CMGST.
Explain that one for us again.
VBUK is the header status table for the sales document.
Hmm.
CMGST is the credit management status field. It has a few key values. A means approved, B means blocked, C means it was blocked but later released by a credit manager.
So you just step through your code and you watch that one variable.
You watch it like a hawk. If it flips from A to B when you didn't expect it to, you know exactly which line of code or which standard check was the culprit.
The source mentions a really common error that drives people absolutely crazy. The order is blocked, but I turned off the check.
Oh, the classic ghost block. I've spent many late nights on that one.
What causes that? It sounds impossible.
It happens because you likely only turned off the static check with your routine. But in OVA8, credit management has multiple layers of checks. There's the oldest open item check, there's the maximum dunning level check, there's a critical fields check.
Ah, so your logic said to ignore the credit limit, but it didn't say anything about the fact that the customer has an unpaid invoice from 1999.
Exactly. And standard SAP checks that as a completely separate step. So if your custom routine 901 is only assigned to the static check line in OVA8, the oldest open item check just runs completely unprotected. It sees the old invoice and it blocks the order.
So what's the fix for that?
You must be thorough. You have to assign your custom routine to every single active check type in that OVA8 screen. The static check, the oldest open item check, all of them. Or you have to place your routine at the very top level requirement to bypass everything below it. You can't just lock the front door and leave the back window wide open.
That is a real pro tip. Okay, last section here, section 9, advanced considerations. We're talking about performance and long-term maintenance.
Right, because it's not enough to make it work, it has to work well. Performance is critical. Remember, all this custom logic happens at the save event. If your code takes 5 seconds to run, the user is staring at a spinning wheel for 5 seconds every single time they enter an order.
Which is completely unacceptable in a high-volume call center environment.
Totally. If you have 100 users entering orders all day, you just slowed down the entire company. So you have to follow best practices. Don't write select from a massive table like VBAK. Select single records. Use indexed fields. And specifically for our little Z table, turn on full buffering in the technical settings in transaction SE11.
Buffering. What does that actually do?
It's a huge performance boost. It tells the application server to load the entire little Z table into its local memory, into RAM. So when your code needs to read the rules, it doesn't even have to make a call to the database. It reads it instantly from memory.
And since the table is just a small set of rules, it's not a lot of data to hold in memory.
Exactly. It's maybe 50 rows, 100 rows tops. It's tiny. Buffer that thing. It costs you nothing in terms of memory, and it saves you a database trip on every single sales order you create.
That's a great tip. Now, what about maintenance? The source mentions this scary word, reorganization. This sounds like a major headache.
It is the price you pay for this kind of flexibility. So let's say you go live, everything is working great. A month later, the business adds a new order type to your Z table and says, okay, we now want to block these as well.
Okay, so the credit manager adds the row in SM30. New orders of that type get blocked. Simple.
New orders, yes. But what about the 5,000 orders of that type that are already in the system? They were created under the old rules. They might be sitting there approved and ready to ship, but under the new rules, they should be blocked. Or you could have the reverse, where you relax a rule.
Does the system just auto-update them when the table changes?
No, not at all. SAP does not go back and recheck thousands of old orders just because you changed a single entry in a custom table.
So you have inconsistent data in your system. You have open orders that are now violating your current credit policy.
Exactly. Unless you run a credit reorganization, there's a transaction, F.28, or the program behind it, RVKREA77. This program is designed to go through every open sales document and rerun the credit check logic from scratch, including your new Z-table rules.
That sounds incredibly resource intensive.
It is massive. It can lock tables. It consumes a huge amount of system resources. If you run this during the day, nobody can save a sales order. You do not run this at 2:00 p.m. on a Tuesday.
So it's a weekend job.
Strictly a weekend job, probably overnight on a Saturday. But if you don't do it periodically, your credit reporting and your system's behavior will be completely out of sync with your configured business rules.
Oh, wow. There really are no shortcuts in this world, are there?
Not if you want to do it right. The system is incredibly powerful, but it demands respect for its processes.
So let's wrap this all up. We started with a fundamental conflict. Business nuance versus system rigidity. We walked through the architecture, we came up with a matrix table solution, we looked at the code in both ECC and S4HANA, and we navigated the really critical gotchas about updating exposure versus just checking.
It's a whole journey. It's a journey from this can't be done in standard to here is the robust, scalable architecture that handles it.
And that really is the key takeaway, isn't it? The difference between a junior consultant and an expert.
A junior consultant looks at OVA 8 and says, sorry, standard SAP doesn't support blocking by order type and customer group at the same time. And you know what? They are technically correct. The standard configuration screen doesn't do it.
But the expert.
The expert says, standard configuration doesn't do it, but the underlying architecture absolutely allows for it. I will build a controlled logic injection that gives you exactly what you need without breaking the core system and in a way you can maintain yourselves. That is the solution architect mindset.
It's about not accepting no from the software, but also not breaking the software just to get to yes.
Exactly. It's controlled, documented, scalable deviation from standard.
I like that. I love that phrase. Control deviation.
Mm-mm.
Okay, before we go, I want to leave our listeners with a final thought to mull over. We talked a lot about hard coding today.
The great enemy.
The great enemy. So here's the challenge for you, the listener. When was the last time you hard-coded a value of plant, a document type, a user ID, because it was just a quick fix? And more importantly, is that quick fix currently ticking away like a little time bomb in your production system, just waiting for the day the business changes its mind?
Woo! That's going to keep some people awake tonight, I think.
I hope so. Go check your code. Thanks for diving deep with us today. We'll see you on the next one.
Happy coding.